we have 46 groundwater sources which exploit this aquifer with around 153 wells. The upper aquifer has 8,700 cubic meters installed, which means 2,400 liters per second, with 23 groundwater sources, including more than 100 wells. The total installed capacity is, as you see, around 10,000 liters per second. This article presents data on the evolution of hydrogeological parameters and water chemistry of groundwater aquifers in southern Dobroja, exploited by water supply system in this area. In recent years, an increase in the nitrate content was found in the groundwater used for the water supply system in a rural area and even in large town systems. The causes of increases in nitrate contained in groundwater, the time evolution of the content of nitrates, and measures to protect geological and groundwater abstraction exploited are analyzed in this presentation. A case study will be presented for the Pecinaga groundwater source located in the southern country of Constanța. Well, I'm going to present a short description, a geological description, and hydrogeological characterization of this studied area. Southern Dobroja represents a part of Moesian platform bounded by north by the fault Capitava-Ovidiu, which is here, and bounded by on west by the Danube River, bounded on east part by the Black Sea, and bounded in south part by the Bulgarian border. As I said, this is Constanța, South Dobroja platform, which is part of the Moesian platform, which is a bigger platform, which is surrounding here. Formation of the Mesozoic and the Neozoic are widespread in the area, which included several sedimentary cycles separated by nearly horizontal discordance. Only a few of these formations are important in hydrogeological terms. Going ahead a little bit. This is your interest area, and it's a zoom here with hydrogeological detail map of southern Dobroja. Okay. In this area, we have a carbonate formation from late Jurassic and early Cretaceous on the whole area, and which stored the lower aquifer. This is the hydrogeological map of the lower aquifer. With 400 meters to 1,000, more than 1,200 meters thickness. The second carbonate formation of summation layer make up the second aquifer, which is here. This is the hydrogeological map of upper aquifer, summation upper aquifer. And this is one part of the aquifer. The aquifer is going to the west a little bit. Boundary is somewhere here. Well, the lower aquifer, which is Jurassic and Cretaceous aquifer, the main flow direction of this aquifer is in Romania territory is from west to east, and discharging area is the Black Sea coast. Is the Black Sea, of course, and occurs mainly in close to Constanța city. Is the main catchment area here. I'm going ahead a little bit to see the catchment area around here, and the main discharging area here. As you see, the flow direction is concentrated to this area close to Constanța city. Okay. The principal recharge area of this aquifer is located in Bulgaria, which this is the discharge area, and recharge area is here. Okay. The transmissivity of this aquifer is ranging from hundreds to more than 150,000 square meters per day. Other information regarding parametric hydrogeological parameters: the slope is usually less than 0.05%. The conductivity is usually more than 100 meters per day. And it is more important, the storage coefficient varies between 10 at -3 to 10 at -4. The aquifer is confined on over 60% in southern Dobruja. The upper aquifer the development of this aquifer is controlled by the existence of an impermeable layer of Senonian chalk. In east part of South Dobruja is a boundary of this Senonian chalk, somewhere here. And this layer separates these main aquifers. The drainage area is the Black Sea as well. The main discharge area is Black Sea through the system of lakes in some parts. The aquifer is characterized by the hydraulic gradient around 0.9 and 0.14%, and the permeability is from 50 to 2,000 square meters per day, with local varies about 5,000 square meters per day. This aquifer is unconfined on 100% of South Dobruja. Go ahead. We start now with piezometric evolution. Piezometric evolution of lower Cretaceous aquifer in a period of 1965 to 2010, and the case is Constanța groundwater sources. We see the trend of this head elevation of piezometric. At the beginning, we had 3-4 meters to 6 meters elevation high, and due to the increasing in rate of pumping, the level decrease, and we see still a steady evolution due to the steady pumping rate at around 3,000 liters per second, and the level of piezometric is around 0. This graph is stopped at 1991, and we continue with from 1989 to our days. We see the trend of pumping, flow out, of decreasing trend, and the same time with increasing level of head of aquifer. This is based on the exploitation is reducing by the necessities, Constanța town necessities. We see a small, but I can't see with this green line. This is the level of lake close to these sources. We see the small changes in on lake level according with piezometric level, which means we have a low hydraulic connection between each. We see the level of lake increase a little bit due to the decreasing of exploitation. You see here, not quite sure. That means this we have a low hydraulic connection between lake and aquifer. The response of this aquifer is immediately on outflow based on that storage capacity. Go ahead with this chart show us a piezometric evolution of upper Sarmatian aquifer from 2000 to 2010, and the case is Pecinaga groundwater source. On this chart, the piezometric evolution show a different situation. On a constant flow, the piezometric level decrease in time. You see the constant flow more or less, and we see a decreasing level of Sarmatian aquifer. This was the response of aquifer to lower this discharge from irrigation system that was increasingly less used in agriculture. As a result, the piezometric level of this aquifer decreased without around 4 meters, because they stopped irrigation, and there was no discharge, vertical discharge from the water from the irrigation in the system. In particular, the evolution of nitrate in groundwater aquifers. The groundwater depth aquifer that supply Constanța metropolitan area is low in nitrate, and in over 30-40 years of operation, there are no significant changes in nitrate content. A special situation presents the Sarmatian groundwater sources of the littoral area, like Techirgor source, groundwater source, Biruința, Dulcești, and in our case Pecinaga, where an alarming increase in nitrates content is found in some of the wells, as follows in chart below. You can see the values of the nitrates at the beginning of the source when they drilled the wells was almost zero or close to zero value, one small values, and you see we don't have values between records between these years. It's a lack of information here, but you can see the increasing of nitrates, sometimes above the limits. The indicators of groundwater values are directly dependent on a number of natural and anthropogenic factors, like geomorphological features, geological and structural tectonics of this area, thickness, extent, and the lithology of the cover deposits of this the aquifer captures, climatic condition of the area, temperature, precipitation, etc., especially in this case of groundwater aquifers, operating regime of groundwater sources, and hydrogeological parameters of this aquifer. Point sources and existing disseminated pollution, like zootechnical complexes, infiltrations from the sewers of the localities. And the last but not the least, the intensive agriculture activity of some chemicals, fertilizers. Nitrate concentration exceeding natural levels due to human activities exclusively. Agriculture, industry, rising domestic wastewater. The chart above shows that the execution of drilling, the nitrate level was low in all cases at the beginning. As I said, the nitrate increases in time because the human activities. As a result, to keep the water quality, especially in these parameters, nitrate, we have to mix different water volumes with low and high nitrates concentration, so as to maintain the nitrates concentration below 50 milligrams per liter at the end. We have to keep in mind that the septic sewage system must be changed with a network sewage system to collect wastewater and treat it. The septic sewage system must be neutralized as a result of high vulnerability to pollution of upper aquifer. The authorities, like Ministry of Environment, should control and reduce or eliminate those other sources of contamination. We mention here the big breeder houses with, let me go back a little bit, which are put here in red, in orange color. You can see big breeder houses. And I'm going to finish now. And the high amount of chemical fertilizer used in agriculture. Thank you. And thank you.